Welcome to this session. Now in this session we're going to leave all that long multiplication and long division behind us. We're going to be focusing today on just terminology. Prime numbers, multiples, products, factors. You're going to see these a lot coming up in the exam. You might even hear your teacher talking about them as well. If you don't know what those words mean, it might feel like you're falling behind, that you don't fully understand what they're talking about. So I'm going to try and show you what we actually mean by those words. Let's start with primes. Now, in the previous session, in division, we were talking about things in times tables, we were counting up, subtracting down, or even using that plus sign method. What happens if we encounter a number that can't be divided? A number that when we do try and divide it, will give us a decimal, so not a whole number, otherwise known as an integer. We will be given a decimal. Now in maths that's absolutely fine, but sometimes we don't want those. Prime numbers are interesting to mathematicians because they are totally random. There's no order to how they appear. Now all that you need to know is pretty much how to count up to the first 10 prime numbers, and you just need to be able to recognize them and understand what they are. So a prime number is a number that can only be divided by itself, or the number 1. Now because of that, 1 as a number isn't considered a prime number anymore, because it can only be divided by 1. So it doesn't quite fit the bill. However, 2 is a prime number, because it can only be divided by 1 and 2. Also, here's a little trick when you're working with prime numbers. 2 is the only even prime number. That's because every other even number is divisible by 2, so it can never be prime. So if you remember that, if I give you a random number, if it ends with a 2, a 6, an 8, there's a 4 there, believe it or not, 2, a 4, 6, an 8, or a 0, it is not prime, because those are even numbers and therefore are divisible by 2. So that's going to be easy for you to use when you're working through your prime numbers. What do you think the next prime number is going to be? It's going to be 3, because it's only divisible by 1 in itself. What about 4? Well, 4's in our list of excluded numbers because they're divisible by 2, so we can cross that one out. 5, that's also prime. It can only be divided by 1 or itself. You can divide it by 2, but then you end up with 2.5, which isn't a whole number, so it doesn't count. 6, again, is on our excluded list, so we can just skip past that one. 7, 8, excluded. Now 9's the first weird number that we come up to, because it's not in our excluded list, but it's not prime. Why do you think it's not prime? That's right, it's divisible by 3. 9 can be divided by 3, 1 and itself. Now because of that, it can't be prime. 10, well it ends with 0, so it's on our excluded list. 11, that's prime. 12 is also on our excluded list. 13 is prime. 14, excluded. 15, it's not excluded, but if you remember the previous lessons that we've done, 15 is divisible by 3 and 5. So it can't be prime. 16 is excluded. 17, that's prime. 18 is excluded. 19, that's prime. And the way that you can tell those kinds of numbers is because, well, if we do the 8 times table, we have 8, 16. We can do the 9 times table, 9, 18, or the 10 times table, 10, 20. 19 didn't fit into either of those. It must be prime. This goes on and on and on. What you're going to find out is that your prime numbers will become more and more elongated, i.e. there are more and more numbers between your primes. There are some special cases further along, but you're looking at like the 361st prime number. And we're not going to get into things like double primes or anything like that. But you will find that there's going to be less and less prime numbers. And all that you need to do is you need to just count through the times tables and overlay that onto a list of numbers like this. Sometimes you might hear this method called the Euclidean sieve, and that's because a Greek mathematician called Euclidean used that method. So those are our prime numbers. Prime numbers are important, particularly in the cyber security industry. They're also important to us in GCSE Maths because we're going to use those prime numbers later on. But for now, just try listing some prime numbers and try and get a feel for what is divisible by itself and just the number 1 or any other number in the times tables. I hope that you found this helpful. Stay tuned for more.